Hello, this is Vinay. I've been working as a ETL tester from past 2 years, and my career started in IT field around 6 years back. Started with manual testing and moved on to automation testing, and currently working with ETL testing. Let me describe the core concept briefly of the ETL testing. ETL testing, the main core content is like we'll be covering the complete course in 30 hours. It's like 30 days, 1 hour per day, and the medium will be online medium or Skype, GoToMeeting and Gmail. So the prerequisites for ETL testing is SQL basics. SQL basics is good knowledge of SQL basics is enough for the ETL testing. And moving on, the objectives of the course will be understanding the concepts of data warehousing, ability to design and develop complex mappings using different transformations, configuring workflows as in real-time environment, troubleshooting errors and failures, gain hands-on experience with multiple exercises and various real-time scenarios and demo project, build confidence to excel your career as an effective ETL tester. The course content mainly deals with three categories. It's like first will be having overview of the data warehouse, and later will be basic ETL and the ETL testing part. The basic overview of video covers like introduction to data warehouse, what is, where and why we use the data warehouse, and next moving on to star schema and snowflake schema, and dimension and fact table, slowly changing dimensions and its types. Introduction to Power Center tool, it's like Informatica tool. And what is ETL? It's like ETL stands for extraction, transformation and loading process. Power Center tools, there are different types of tools in Informatica Power Center: repository manager, repository designer, workflow manager and workflow monitor. Next moving on, source and target object definitions, transformation concepts, types classification and basic uses, ODBC and relational connections. Okay, and moving on, there will be how we will be working on different types of transformations. Firstly, we will be working with how do we work with flat files like Notepad files and MS Office, like all these kind of those come under flat files. So we will be covering the topics of flat files and moving on with XML files. And later we will be moving to transformations, where we have different types of transformations and it's like there will be around 10 to 15 transformations which used for different purpose, and there are rotor transformation, sequence generator transformation, rack transformation and so on. And there are different types. Each transformation is meant for specific purpose, and we will be discussing them in the course. And the advanced ETL concepts will be like the different types of loading types and slowly changing dimensions. We will be covering like type 1, type 2 and type 3, and indirect method of loading the data. Moving on, ETL test cases, creating ETL test cases, how with different types of transformations, how do they work, and each transformation test cases will be shown practically. Okay, and let's move on to the demo for introduction to the data warehouse. What is the data warehouse? Why do we use, and what is the purpose of the data warehouse? It's like data warehouse. The data warehouse is object-oriented, integrated, non-volatile, time-variant collection of data in support of management decisions. So it's like one of the database where we will be using for the management decisions, and it's also a database where the data is used for decision making. It's not for the storage transaction purpose. It's only used for decision purpose. So what is integrated? Characteristics of data warehouse. So we have a sales database in Hyderabad and one more sales database in Chennai, where the data is being extracted from using Informatica tool and loaded into the Informatica staging area. And moving on, it will be loaded into the data warehouse. So we are integrating data from different databases using Informatica tool. So okay, next, non-volatile. Non-volatile is like operational database. Operational database is like daily transactional database, where we can insert the data, we can change the data, we can delete the data, we can replace the data, and all operations are possible in operational database. Whereas in data warehouse, once we load the data into the data warehouse from operational database, it's only read only. We cannot change the data once it's being stored into the data warehouse. It's only used for read-only purpose, where we use this for analysis and for reporting purposes. Okay. Next, subject-oriented. Data warehouse is subject-oriented which support business needs for individual departments in enterprise. It's, for example, sales, HR, accounts, and loans. These are different types of databases which we store as individual databases in data warehouse, data marts. Okay. Moving on, time variant. See, we will be storing data in operational database. We will be storing only the 60 to 90 days of data. It's like only within the days. It's not like years. You cannot store the historical data in operational database. As in data warehouse, we will be storing the historical data, which is used for analysis and business decision making purposes. For example, for this best example is ATM center. When we go to ATM center, will we go and take the mini statement of the account, we will get only the past 5 to 6 transactions. We will not be getting the complete yearly transaction or complete month transactions. That's a big example for operational database. Whereas in data warehouse, when we go in online and when we log in into the bank account, we can get the statement for past 1 year. Max we will be getting past 1 year transaction within the statement. So that is the best example for data warehouse. Okay. Moving on, data warehouse is a database which is specifically designed for analyzing the business but not for business transaction processing. That's the main definition of the data warehouse. Okay, it's used for analysis purpose. It's not for transactional purpose. Okay, what's the difference between OLTP, online transaction processing system, and data warehouse? It is designed to support operational monitoring. It is designed to support decision making part. Data warehouse is designed for decision supporting process. Okay, data is volatile, data is non-volatile. Current data, it stores historical data. Okay, these are different types of differences between OLTP and data warehouse. Operational system, detailed data will be storing in data warehouse, will be storing summarized data. In operational databases, data will be stored in normalized form. In data warehouse, it is stored in denormalized form. In operational database, related to smaller database, data warehouses are very large database. Designed for support ER modeling, designed to support decision modeling. Okay, these are architecture of the data warehouse. We will be having different sources like Oracle database, SQL database, flat files like MS Office files and XML files. Everything comes into the sources. We will be loading the data from sources, different kinds of sources, into the staging area of Informatica and loading the data. After doing the manipulation, we will be loading the data into the data warehouse. Once the data is loaded into the data warehouse, we will be using the data for reporting purposes. Okay, that is the architecture of data warehouse. Data warehouse is one more diagram of the data warehouse architecture. These are the source systems. Informatica, by using Informatica, we will be loading the data into data warehouse. Data will be used for decision making for reporting purposes. Okay. Data acquisition. It's a process of extracting the data, relevant business information, transformation, the data in required business format and loading into the data warehouse. So it is defined in the following process: data extraction, data transformation, data loading. Okay. What is ETL? ETL stands for extraction, transformation and loading. The process of updating the data warehouse. ETL is the process of updating the data warehouse. ETL is automated and auditable data acquisition process from source system that involves one or more sub-process of data extraction, data transformation, data consolidation, data integration, data loading and data cleansing. Okay. Need for ETL. What is the purpose of ETL? Why do we need ETL? The process of ETL is required so that data from different heterogeneous sources can be combined and brought into one common source. See, there are different times we will be getting data from XML files, we will be getting data from MS Office files, we will be getting from Oracle database, we will be getting data from SQL Server database. So all this data which is coming from heterogeneous can be combined and put into one data warehouse. The main advantage of ETL process is that. Okay. The advantage of having the process of ETL is that as the data from different sources can be brought together, highly complex and user-friendly reports can be generated for decision making. Okay. Data is stored in different formats in different types of databases. Okay. So some data sources may be achieved where others may be active operational system. Data extraction and cleaning, time consuming and aggregation of data. This is the main need of ETL process. What ETL is not, never creates new data. Once if a list of 100 employees is being loaded, one more employee cannot be added into the list and make it 101. Or if last name of customer is absent, arbitrary last name cannot be substituted. Once the data is loaded into the data warehouse, it's not possible to edit the data. Okay. Data warehouse are not OLTP system. That what means they are not the transactional system. They are only for decision making purpose. Okay. Feature of ETL tools supports data extraction, cleansing, aggregation, reorganization, transformation, and load operations. Okay. Generated and maintained centralized metadata. Filter data, converts code, calculate derived values, map source data fields to target data fields. Automated generation of ETL programs, closely integrated with RDBMS database, high speed loading of target data warehouse using engine-driven ETL tools. Advantages of using ETL tools: GUI based design of job, ease of development and maintenance, generation of directly executable code, engine-driven technology is fast, efficient and multi-threaded. These are the different advantages of the ETL tools. Okay, this is one of the presentation of the ETL tool. Data acquisition, data extraction. Data extraction is the process of reading the data from various data types sources such as relational sources, ERP sources, mainframe sources, XML files and flat files. So it's a process of extracting the data from different types of sources. Okay, for example, relational, Oracle, SQL Server, ERP, SAP, PeopleSoft, mainframes, COBOL and files, and DB2 files like flat files, text files and XML files. Okay. Data acquisition is a process of cleansing the data and data transformation. Is the process of cleansing the data and transforming the data into required business form. The following data transformation activity takes place in staging area: data merging, data cleansing, data scrubbing, and data aggregation. What is data merging? It is a process of combining the data from multiple inputs and loading into single output. There are two types of data merging activities: join and union. By using join, you can join multiple tables data, and union you can join multiple table data. Okay. Data cleansing. It is a process of removing unwanted data from staging. It is a process of changing inconsistencies and inaccuracies. You need cap and route functions. See, and we have it's like 10.0008, so we can just round it to 10. So like this is the example for data cleansing. Data scrubbing is a process of deriving new data definitions using existing data. Example, concatenate first name and last name. Okay, that is the example. Data aggregation is the process of calculating summaries for a group of records using aggregate functions: average, max, min. Examples of aggregation. Data loading is the process of inserting data into target system. There are two types of data loads: initial load or full load, incremental and delta load. Initial and full load is the process of loading all required data at very first load. Incremental and delta load is the process of loading only new records after initial load. Okay. Data merge. Data merge is a simple form of data warehouse that is focused on a single subject or functional area such as sales, finance and marketing. Data merge are often built and controlled by a single department within an organization. There are two types of data merge: dependent data merge and independent data merge. Data merge. Top-down approach or dependent data merge. According to WH involved, first we need to design an enterprise data warehouse, then design a small form of subject-oriented department design specific database known as data merge. This is the pictorial representation of top-down approach. First we will be loading the data from different sources into the data warehouse and then moving the data into different types of data merge. It's marketing data merge, sales data merge and financial data merge. Moving on, data merge bottom-up approach. According to Ralph Kimball, first we need to design department-specific database known as data merge, then integrate all data merge into enterprise data merge. This is a pictorial representation of bottom-up approach. Once we loading the different data from different data sources and moving them into the different data merge, marketing data merge, sales data merge and finance data merge, later moving that into the data warehouse. Okay. What's the difference between data warehouse and data merge? See, these are the different types of differences. This is a property, data warehouse and data mart. So scope of the data warehouse is enterprise, scope of data mart is department. The scope, the subjective is data warehouse subjective is multiple, data mart subjective is single. Data source subjective, data warehouse data source is many, data source for data mart is few. Implementation time months to year, months. Okay. There are dimension modeling. Next, dimension table. Dimension table contains textual information that represents attributes of the business. contains relatively static data. Dimension tables are designed to a fact table through foreign key, are joined through a fact table through foreign key reference. Dimension table example, retail. In retail table, store name, zip code, product name and product category and day of week. Those are the table columns of the retail database. This is the example of dimension table. Fact table contain numerical metrics of the business, can hold large volumes of data, can grow quickly. Okay. Fact table examples: retail number of units sold, sales amount. Telecom length of call in minutes, average number of calls. Okay. These are the examples of fact table examples. Types of schema: star schema, slope schema, galaxy schema, fact cancellation schema. These are different types of schema available. There are the going forward. Star schema. Star schema is one in which a central fact table is surrounded by denormalized dimension tables. A star schema can be simple or complex. A star schema can consist of one fact table, whereas complex star schema has more than one fact table. This is a pictorial representation of star schema, where it's been surrounded by one fact table is surrounded by different multiple dimensional tables. Okay. Snowflake schema. Snowflake schema is an enhancement of star schema by adding additional dimensions. Snowflake schema are useful when there are low creditability attributes in the dimensions. This is a pictorial representation of Snowflake schema. Okay. Snowflake schema. Galaxy schema. Galaxy schema contains many fact tables with some common dimension, compound dimension. This schema is combination of many data modes. This is a representation of galaxy schema. Okay. Fact cancellation schema. The dimensions in this schema are segregated into different dimensions based on the level of hierarchy. For example, if geography has 5 levels of hierarchy like territory, region, country, state and city, cancellation schema would have 5 dimensions instead of 1. Compound dimension, a dimension table which is shared across data modes or more than one fact table. Example, calendar, date, time dimensions, customer dimension, product dimensions. Okay. Slowly changing dimensions. SCD captures say changes which take place over a period of time. SCD type 1. Type 1 dimension keeps only the current values, doesn't maintain the history. SCD type 1. Okay. Whereas SCD type 2 dimension maintains the full history in the target. For each update, it inserts a new record in the target table. LCD type 3. Type 3 dimension maintains current and previous information, partial history. Okay. This is slowly changing dimension types. Okay. This is a demo for the Informatica. Thank you.